Okay, so the next one is going to be another explosion. So this first one that we saw was, I would say, more of a combustion explosion, definitely involving combustion. And you saw fire, basically, right? Here, we're going to do, this one we're going to do outside. It's a little more dangerous, and it's going to be a pressure explosion. So there's not really going to be any fire involved, but it's still very violent. So what we're going to do for that is we're going to take this, which is pretty much a dewar for liquid nitrogen. So in this here, you can kind of hear it, and it comes out a little bit. You hear that sizzling? All right, so it's actually boiling right now. So this is I'll actually pour some in this water bottle ahead of time, so that to get you to see what it looks like here. Before I pour it, I'll use safety glasses just in case. I don't want it to splash into my eyes, even though I am pretty protected with liquid nitrogen because of the Leidenfrost effect. Pretty much this is so cold that anytime it touches anything out here,
it will vaporize and float on a cloud of its own vapor, kind of like when you put water in a very hot pan.
So let's go over that real quick. So pretty much liquid nitrogen is about 77 Kelvin, which is about negative 196 degrees Celsius. So imagine this. You take the boiling point of water, which is what? When does water boil? 100 degrees Celsius, right? 212 degrees Fahrenheit. So imagine 100 degrees Celsius water. You wouldn't want to stick your hand in that, right? Now negate it. So now you're at negative 100, and then double it. Now you're at negative 200. So that's how cold this is. So you definitely, it's very dangerous in the opposite direction. So you'll get frostbite. Like your skin cells cannot survive at this temperature. But you have a certain window of safety because it's so cold that it actually vaporizes before it ever touches you. Unless you actually come in direct contact with the liquid, and then you're going to get burned. So you do have a little bit of a safety net. So like I literally could stick my hand in there, I literally could pour it on my hand, and I would be fine. But I'm not going to risk it. So usually we wear these like cryogenic gloves, and this helps a little bit. It says it's waterproof, CryoGuard, and then you wear this to prevent it from splashing in your eyes, just in case. So I'm going to pour some in this water bottle, and then you can kind of see what's going to happen. So you can kind of see what it looks like. It's boiling right now. Okay, you see it at the bottom there? So it's boiling. See that? It's transparent. It's pretty much liquid air because 80% about of the air that you breathe is nitrogen gas. And if you turn it into a liquid, then this is pretty much what it looks like. And then it boils at room temperature. Now notice, you can kind of see smoke. You're not actually really seeing the nitrogen. What is this stuff right here, this frost? What is that you see forming? What is it? The air. What in the air is condensing and freezing on here? Water vapor. So water, do you know how water on a cold glass condenses into a liquid? Mm-hmm. This is so cold that it's not only condensing into a liquid, it's also freezing into a solid. So you have solid water from the air that is coming onto the surface of this bottle because it's so cold. So very, very cold stuff. Now, the other thing to understand is that this liquid nitrogen, when it turns into a gas, is going to expand. So let's try to give you an illustration here. So let's say that this is an illustration of a certain amount of liquid nitrogen. Now, this is I'm going to put L for liquid. Now, when it turns into a gas, it gets a lot bigger. So this is definitely not to scale. But imagine that this amount of liquid turns into that amount of gas. Once it turns into a gas, it takes up hundreds of more amount of space. Like literally, the amount of space it takes up as a liquid, multiply that by hundreds. I think it's like 700 or something like that. And that's how much space it takes up as a gas. The problem is, if you have it in a container like this, and then you put the cap on, then it becomes a container, and it's trying to contain that gas. But it can't, because there's so much gas being produced as it bubbles that it's going to generate so much pressure that eventually that pressure builds up and it just explodes and it's pretty much a pressure bomb. So that's pretty much how we're going to do this. You can do something similar with dry ice. You ever seen anybody put dry ice in a water bottle or something and put the cap on? Now it's dangerous. Like, it's definitely depending on the strength of the container. So if you're using a pretty weak container, then it's not going to be as violent of an explosion. But if you're using a very strong container that takes a while to build up pressure, it's more and more pressure, it's more and more violent, and more energy is being released as it explodes. So you want to be careful, and that's why we're going to do this outside. Because we're going to take this pumpkin, pretty much what I'm going to do is put the cap on this, pour some liquid nitrogen in there, put it inside of the pumpkin here, and then put the top of the pumpkin back on the best I can, and then it will explode. The other thing I'm going to do is I'm going to put some water in this pumpkin first on the bottom, and then that way the bottle is sitting in some water so it doesn't take forever, because I do want this to happen within about a minute, and if I don't use water, I found that it takes a lot longer. So I'm going to pour some water in the bottom of this pumpkin. I'm going to take the liquid nitrogen bottle, cap it off. It's going to start bulging. It's going to start building pressure. Put it in there quick. Put the top on, and then it's going to start vaporizing, building up pressure, and eventually this whole pumpkin's going to explode. So that's the general idea of what we're doing right now. There's a lot to learn about liquid nitrogen. We're not covering all that today, but we are going to cover just the basics of how this works in a pretty interesting way with an explosion. And we will learn more about liquid nitrogen later on in the year. Okay, so any questions so far? Good? All right, so let's go outside and let's get this done. All right. All right, so we're outside now, and we're going to pour liquid nitrogen into this water bottle. It's got a little bit of water in the bottom. Then we're going to put the top on, and then we're going to run away. All right, so that's how it's going to work.
Oh, that's awesome.
And this is all that's left. Just a little bit of a water bottle. You can see how that cap is a little bit intact here, but the rest of it is not. So, awesome.